All right. Now, in 8.5, the last section, this is going to be helpful for our quiz tomorrow. There's not x-intercepts on the quiz, but the graphing and the axis of symmetry stuff is going to be helpful for your 8.3, 8.4 quiz. The x-intercepts of this graph, you should have them at -2, 0, and 2, 0. X-intercepts, -2, 0, and 2, 0. You're welcome to change anything. You need to use this information as feedback. What's the axis of symmetry? In the case of this one, it's x equals 0. The AOS is x equals 0 because the x value of the vertex is sitting at 0. X value of the vertex is sitting at 0. That makes the axis of symmetry x equals 0. Is that everything? It is. When we go on to number 2, the two x-intercepts are -1 and negative x-ints are at -1, 0 and -4 and 0. If you're writing them as an ordered pair, make sure you're putting them with 0. Make sure that you got them with 0. Now the axis of symmetry on this one, ooh, that's looking like it's maybe -2.5. Axis of symmetry goes down the middle, and that is when the x value is halfway between -2 and -3. So that axis of symmetry for this one is the equation x equals -2.5. I've had people even ask me today, does it matter if I put x equals? You do. It is a vertical line that has an equation that is x equals something. These are the equations of a vertical line. Now in 3 through 6, these all took graphing, and I actually graphed them already. So when I switch over to this, I'm gonna go on my paper and make sure that I've got the vertex, axis of symmetry, and x-intercepts labeled, and then also domain and range. A lot of people that turned this in the first time did some stuff but didn't have domain and range, so make sure that you're either putting that on your drawings or coming back and writing it here. So like here's the graph for number 3. The function was x plus the quantity x plus 3 times the quantity x minus 1. So I'm looking for, you come over here and you say the vertex is -1, -4. The vertex is at -1, -4. That goes right along with, let me go in and put my axis of symmetry. My axis of symmetry equation is x equals -1. I can knock those two things off together. Your axis of symmetry equation is x equals -1, goes right along with your vertex. What else did it want? X-intercepts. X-intercepts are sitting here, 1, 0, and -3, 0. Those are my x-ints. Now, domain and range. The domain of this function, there's not any reason for us to believe that we can't put any value for x in. There's no reason to believe that we can't put anything in for x. So our domain is going to be x is all reals. X is all real numbers. Now the range has to do with the y values, and we know that this parabola has a minimum. This is the kind of thing that keeps showing up on your, that's going to show up on your quiz. Absolutely showing up on your quiz, yeah. Yep. And the range is going to be y values that are greater than or equal to, the lowest point it goes is -4. Greater than or equal to -4. Make sure that you're comfortable with domain and range. We can talk more about it too before we get out of here today. So I've got my vertex, my axis of symmetry, both x-intercepts, and domain and range. That asks for a lot. Make sure that you're reading the directions for your quiz too. Now when I go over to number 4, here's the graph for number 4. And again, I'm going through these quickly because this isn't the first time you should be looking at this. The vertex of this one, what is that point, you guys? 2 and what?
9.
Is it 9?
I would think 9.
2 and 9, yeah, it looks like 9. You tell me.
No, I'm looking at my graph.
Axis of symmetry, x is equal to 2. And then what are the other things they want on here? We've got to go, I had a blue marker. My x-intercepts are at 5, 0. That's an x-int. And -1, 0 is the other one. And then I'm going to go over here for domain and range. Number 4's domain No reason why I can't say that 4 can have any x value. Domain, x is any real number. Then the range can only go as high as this maximum point, which is 9. So y has got to be less than or equal to 9. Domain and range. This seems to be the biggest place where people are just kind of don't really understand or just haven't really gotten it down how to talk about it. The range, when parabola opens down, we always say the range is going to fall. The y values are always going to be below that maximum point. And we use the minimum on the other one. Number 5, the graph was kind of tricky. Some of you might have to come back and do a different graph of this. But I had already written down what the vertex was because when I graphed this, it was so low. I went by, I think I went down by 2s, and I still kind of had to go below it. The vertex in 5 is 4 and negative 32. That vertex helps us with the axis of symmetry equation. Axis of symmetry equation, x equals 4. And then, what's next? X-intercepts. If you need to run out and get a drink, sweetie, you can. Just prop the door open so you're not locked. X-intercepts, where's this hitting? 8 and 0? 8, 0 is one x-intercept, and 0, 0 is another one. And then domain is going to be, x is all real numbers. We can put anything for x in, and it's going to spit out a unique y value. We can put in anything for x. The range is going to be y has to be bigger than this minimum. So domain, same, x is all real numbers. Range, y is greater than or equal to negative 32. Number 5's range, y is greater than or equal to negative 32. I had a lot of people that were clearing this stuff up just yesterday and today, understanding how to calculate or how to describe the range. When I go over to number 6 has got a vertex that's sitting at, help me out you guys, what is it? Negative 4 and what?
Negative 4 and 9, negative 9.
Vertex negative 4 and negative 9? Seems all right. That makes my axis of symmetry equation. X equals negative 4. X equals, make sure you got that. Oh, I'm going to even put my axis of symmetry in. X-intercepts are at negative 1, 0. And thank you. Cool. And then, oh, that's an X int too. And then I'm going to come over and talk about my domain and range on my paper. If you've got your domain and range on your graph, that's fine. My graphs are just filled up with all kinds of stuff already. I wanted to put it here where there was more room. And so domain, X is all reals. Range, Y is greater than or equal to negative 9. It can actually be negative 9 because it does hit that negative 9 place. So make sure you have the or equals too. And I think I even said this to you guys yesterday, but boy, is this getting redundant. You know what I mean? We keep doing the same things over and over. That's why I'm hoping that with this next quiz tomorrow that, it's going to be today for the kids in the morning, but I hope this next quiz tomorrow makes, can help your grade some, that you guys have figured this stuff out. Find the zeros of the function. Now, number 7. So people were talking about how this is making some light work. When you're in this intercept form, we had, I'm looking at the back of the board, the intercept form that shows these intercepts with the zeros is when we have x minus p times x minus q, and those p and q values are zeros. So on number 7, it should be pretty easy to pick out. One of the zeros is 5, 0. The other one is 9, 0. X minus what? That's 5. X minus what? That's 9. Doesn't even matter that this is going to flip it and make it skinnier. Those zeros are still going to hit the x-axis at 5 and 9. You can pull it out of the equation for number 8 because it's in that intercept form. X minus what is x plus 3? This has got to be negative 3 and 0. X minus negative 3 to get the x plus. And the other one must be 2 and 0. Those were sitting there that I can see them. Now these, on the other hand, we can go into our calculator and find them. But actually, I'm going to show you guys. You didn't have to do this, but I'm going to factor these two. If I do x minus, let's see here. Did anybody have the zeros for this one from your graph? 10 and negative 3. Positive 10 and negative 3. Now, this is what this equation would look like. And if you think about, usually when I bring this up and talk about biology and a Punnett square, I just factored or undid this type of multiplication. I just undid x minus 10 and x plus 3 by factoring. And this came up in Algebra 1. Doesn't mean you're great at it. If I fill in the boxes here, I'll show you guys how this product is the same as what we had. That's x squared. That's negative 10x. This is positive 3x. Here's negative 30. I'm multiplying to fill in the boxes. If I add together like terms, you guys see how I was here? Yeah. Yep. So you probably went in, I would expect that you put this in your calculator and looked at the graph or the table to get the zeros of 10 and negative 3. But I just want you guys to, I want to show you guys that you can also get those by factoring. And the question is, what two numbers multiply to negative 30 but add to negative 7? Negative 10 and 3 multiply to negative 30 but add to negative 7. So that's why I could explain it to you that way. The whole idea of undoing that lengthy distributive. And then in 2, let's just go, or in 10. So in 10, if you're like, what the heck is she wanting me to do now? You don't have to factor. You just go in 2x squared minus x minus 10. And remember, we're looking for, that is not x squared, that's just a 2. We're going in to see where does this parabola hit the x-axis. It's looking like it's at negative 2 and maybe 2.5. Negative 2 and maybe 2.5. Yep. Negative 2, there it is. And sure enough, between 2 and 3, I see it pass by 0. Check this out. I'm going to change my table. I don't want you guys to get too crazy here. I'm going to change my table and make it go up by half. And let's see if we can't see that 2.5 in there. So see how my table is now going by halves? When y is 0, x is negative 2. Let's go find the other place where y is 0. Yeah, it certainly was 2.5, halfway between those. So the zeros on this were 2, 0, and negative 2, 0, and positive 2.5, 0. Cool. Now, when you got to go in and graph those functions, like we go down to number 11, 12, 13, and 14, when we're going in to graph these, it says use zeros to graph. I wrote the functions on my paper. I'm going to come here. Now, in intercept form, I know that these zeros are going to be, this must be x minus negative 1. The zeros are going to be at negative 1 and positive 3. I know my parabola is going to pass through those points because it's in this intercept form. What I need to do now, though, is just go find out where this vertex is in order to drop a couple other points on this line, or on this parabola, so I can get a decent picture. There it goes. See, it's hitting at negative 1 and 3. Let's go down and find that vertex. I'm just going to go to the table and grab a few values. Oh, my table. Let me change my table back to go by ones. So I'm going to go to my table and get a couple more values. It looks like the vertex is maybe at 1 and negative something. Yeah, there it is. The vertex is at 1 and negative 4. And then actually at 0, I can go down to negative 3. And then 2 goes down to negative 3 as well. So I can get the whole picture. Now with number 12, looking at the equation in 12, I know it's going to hit the x-axis at, this would have to be negative 2 and negative 6, coming out of the factored form. Negative 2, 3, 4, 5, 6. And then this is going to open down. So where is my vertex up there? Anybody have the point for the vertex on this one? If you were ready to turn it in when you walked in, you would have it.
I zoned out. What number we on?
Negative 5 and 8.
Is it negative 5 and 8?
I didn't write it down. I
Yeah.
just graphed it. I didn't write them down.
Negative 4 and 8. -4 up to 4, 6, 8. And then a couple other points there would be, I could put on -5 and 6. And that would make -3 go with 6 as well, the idea of the symmetry. There's those two. Make sure your graphs are accurate. I feel like there should be more to do with this. No, it was just use zeros. 12. 13. Where are the places that the graph hit the x-axis in 13? I don't know. Oh, I might be able to know. Let me see if I can factor this real quick. Tell me if I'm right. Two numbers that multiply to 21 and add to -10. It should be x minus 3 and x minus 7. Tell me something, you guys. Are the zeros at 3 and 7? 3 and 7. So that was, I factored it. You would have probably got that out of your calculator, but I just want to show you again. Multiply to this number. -3 times -7 is 21. Add to this number. -3 plus -7 is -10. And then how about the vertex of this graph? Anybody have that? You can give it to me quick like. Nobody has the vertex. 5 and -4. Thank you. 5, -4. Looks like I can go 4, -3. That would make a 6, -3 as well. Go in between your table graph and all that. Got to make sure you got it down pat. And I know the tougher stuff is on the back side of this document here in a minute. Now, X14. Let me see if I can't think fast and factor. Factoring is one of my favorite things to do. Two numbers that multiply to -6 and add to -1. I think it's going to have to be -3 and +2. Is that right? -3, +3 times, no, -3 times +2. No, I think I got it backwards. Shoot, I'm trying to do this on the fly. I think I have it backwards. What do you guys have marked as your zeros? Okay, I had it backwards. -2, +3. So it would have been x plus 2, x minus 3. It's the opposite of what we pull out. And then where's the vertex of this one? Should be down here somewhere. Where's the vertex? 0.5 and something? So on this one, you guys, if we're looking for the vertex in our table, A is 1, B is -1, C is -6. The x value of the vertex, opposite of the B up top, all over 2 times the A. That's going to give me a +1 over 2. Sure enough, it's at a half. If I plug in x as a half, I remember doing this in my calculator actually. And what I'm hearing from the crowd here, you guys said this is 6. Are you sure? +6 or negative? I think it's got to be negative. It's got to be. I don't even have to go to my calculator to know that it's got to be negative. And then you could put a couple other points on here, but I've got the vertex. Anybody have any other points, like -1 something? 2 something? Yeah. In a minute. All right. So getting it graphed, and I didn't put it back in there. If you've got a couple more points on there, fantastic. Now, besides the graphing, this last part, I think, is where, here we go. This had been, all I had done on these was wrote down some of the formulas, you know, just to get you thinking about what these could be. Now, it's kind of an interesting indication to me if some of you guys have all the same equations on this. It makes me wonder who did the work, because in all honesty, there's more than one answer for most of these questions. You could do more than one thing. Now, when it's given me a vertex, I wrote down, let's put something in vertex form. So I'm interested, you could let your A be anything. Y is equal to, it's just got to be x plus 5 squared plus 4 on the outside. You could have any value of A. Any number for A could go right out front here. It's still going to have a vertex at -5 and 4. Any A can be here. So I don't know what A you want to put in, but any number you put there would work. The vertex would still be -5 and 4. Now, I can say the exact same thing about number 16. It's given me 2 x-intercepts, 2 and 7. I could have a bazillion different equations. That's not a number. Bazillion is not. I could put any number in for A. Anybody could have any number in for A. It's just got to be x minus 2 quantity times x minus 7 quantity. Anything in there for A. Put a number on your own paper. It shouldn't be what's the same on somebody's next to you, because if you're thinking through this, this should make some sense to you. Your A could make it up, down, whatever. It's still going to hit the x-axis at 2 and 7. Now, this next one is a little trickier because you actually have, besides having those zeros or those x-intercepts, so with this one, I started out here, and I'm kind of like, do I need to put in a value for A? It's x minus negative 3 or x plus 3 times x minus 1. Now, this is all fine and good, and it satisfies this part of the situation. If I go into my calculator now, I want to go see, is negative 1 and 8 in this table? And if not, is there something I can do or some A value I can mess around with to put in the equation to make negative 1 and 8 be in my table? So right now, I'm just going to go here. I'm going into the table. I put that, what I started with, x plus 3, x minus 1 in parentheses. And then second graph at, you guys know, at negative 1, it's negative 4. Huh. At negative 1, it's spitting out negative 4. Any idea what we might do to get from negative 4 to maybe positive 8? What happens if we put a 2 there, like maybe double it? If you go and insert a 2, I'm going to second insert. If I put a 2 there, is it now negative 1, negative 8? Oh. It's supposed to be negative 1, positive 8. So this is what 2 made it look like, and 2 has negative 1, negative 8. Shouldn't be positive 2 out front. It's going to have to be negative 2 out front. So this one, there is only one answer, and the only reason I know that is because when I go and look at my table, that's a minus sign, I put a negative out in front of there. When I put negative 2, do I have that 1 and negative? I do. When I put negative 2 out front for the A, there's my negative 1 and 8 in the table. This answer has to be identical for everybody, otherwise you don't have that point there. So this one is the only answer, only way. Now, with number 18, holy cannolis, number 18 honestly has more ways than anything, because the only thing it's saying is that its axis of symmetry is along x equals negative 3. And I took that information and I said all it's doing is giving me a fixed x value of the vertex. So your equation for this one, and because we're in vertex form, you could put anything in for A. It'd have to be x plus 3 squared, and you can put anything in for the y value of the vertex. This could be any, and this A could be any. That just has to be the case if the vertex is going to hit negative, if the axis of symmetry is negative 3. That makes our x-axis of the vertex negative 3. A lot going on with these. You wouldn't have to have anything here, and you'd still be satisfying it. That alone would satisfy the condition. This all by itself would be true. You can just make it fatter, skinnier, or flip, and you can move it up and down. Now I've got, if you guys didn't notice, these are y values of 0. That makes these the x-intercepts or the 0. These were kind of in, hidden, passes through these points. That's got to get you at x minus negative 4, x minus positive 4. And you could actually, anybody could change this equation with any A you want to put in here. Any A would fit there. Anything. Fat, skinny, up and down, it's still going to pass through negative 4, positive 4.